This is our first time posting this series, so you guys are like the first group of people, and we weren't sure what the reception would be. And it's been phenomenal. Hundreds of people have signed up for an online webinar, which is just incredible to see. And so I mostly wanted to start by giving an overview of why we even set this up. And our goal really is to create a community for AI engineers to learn about MCP, about agent development. Those are things that are that a lot of people speak about a lot, but I think there's so much noise in the system, and there's also a lot that can be clarified. And we wanted to create a space where we can just truly get together and learn, and have people who are experts in that space come and talk and share some of the innovations that they're working on. And so our goal is really to try to break through that noise. And we want to focus on developers and focus on technical innovations. And also, at least what we've seen from talking to customers and building agents with MCP, we're seeing these AI application architectures fundamentally changing in this like over the last few months. If you think about it, MCP itself wasn't even a thing until the beginning of this year. And so how we build AI applications is fundamentally changing, and we want to create a space where people can kind of keep up with all the changes that are going on. And really, the goal is to shine a spotlight on you. We have incredible speakers who I'll introduce in a moment. And really, the goal is not to, be an ad for any product or any one company. It's about a space to learn and just connect with cool people who are building cool things and building on top of MCP and building agents. And so really, that's the goal of the series. One of the things you probably noticed is it's called Silsila. Silsila is a word that means chain of events in Urdu, which is my mother tongue. And I actually thought about naming mcp-agent like Silsila because it's a chain of events that, you're having agents go through and accomplish a series of tasks. And so we thought that would be a fitting name for also a gathering of builders and researchers and developers who are building agents powered by MCP. And so we're going to call this the Silsila webinar series. And for those who are here in the inaugural one, you're in on the inside joke, and the other folks can just like not know why we called it Silsila, but it'll be a fun little thing that you can all remember. And so I want to get started today. Like I said, the goal is to shine a spotlight on others. And so I'm super excited that we have some amazing speakers to join us today. First, we'll start with Thor, who is from ElevenLabs. He's a developer relations engineer, and I'm very excited to see what he's going to show in terms of agents and MCP and what ElevenLabs is doing. Then we have Batuhan from Dria, who's the head of business operations, and he's going to give a demo as well. And so I'm also about agents, and I believe there's MCP agents involved in that workflow, so can't wait to hear that. And then the theme that I wanted to keep today, as I kind of like moderate some of these demos and discussions, is around deep research and kind of the architectures that we're starting to see for agent development. And so I'll talk a little bit about what we're seeing and do a quick demo, if time permits, on doing a deep research finance agent. And so without further ado, I'll stop sharing so that Thor can get started.
Awesome. Thanks so much for having me. Hello, everyone. I'm Thor. Now, my demos are very far away from the deep research finance agents. So I have the pleasure of doing a bit more of the fun kind of wacky stuff. So we'll see if it works. Let me just share my screen. Can we all see that?
Yep.
Fantastic. Yes, so loosely around chain of events, which I think is a good kind of introduction here. So I don't know if folks have heard of Beeper. It's a really neat tool, actually, kind of getting all your messages into one place. If you're building community, if you're building a company, right, you'll have a lot of messages on X, on LinkedIn, what have you, and kind of staying on top of all these inboxes can be quite challenging. So I'm very excited that Beeper, I think they joined Automatic a while back, and there was a hackathon actually at the Automatic office here in New York, organized by Adam from the Simple Co. And it's really cool. They opened up kind of the Beeper MCP here, which basically now means that you can use MCP to access basically all of your different inboxes. And so you can see here, I'm just running kind of the MCP server for Beeper locally on my machine. I got all kind of the messages here. You know, we're kind of aligning here. Thanks so much, Hanya, for, you know, kind of organizing this and pulling all this together. And so what we can do now is we kind of, you know, put all these chain of events together, and hopefully this will work. We'll see. So if we're here in Claude, actually, is it general? Now I'm stuck in the settings. Can someone help me out? How do I get out of the settings? No.
I think if you can click the icon next to settings title, might work, maybe.
Oh, this one. There we are.
Yeah.
Very good. See, okay. Here we're already struggling. So let's create a new chat, and we can say maybe summarize in 2 sentences the conversation with Hani. Is that correctly spelled?
Yeah.
And so we can now hopefully it'll see that Beeper, okay, use Beeper LinkedIn. So I guess we'll have some kind of tool. Okay, so Beeper functionality, no, come on. Well, there we go. This is always live demos where, okay, there we are. Okay, so now we have, you can see, you know, I need to allow, I kind of wanted you to show that this is, come on, summarize the chat with, yeah, in 2 sentences. There we go, come on. Okay, now we're finding the chats, hopefully. Okay, we found the chats. Okay, now we're searching the messages. So we're kind of making our way through it there. And so you can see conversation was about organizing an MCP agent, you know, hour. So this is where we are here, you know, perfect. We made it. So that happened. Now the exciting thing is, you know, ElevenLabs, we just launched the music API. So what we can do now is compose a song with ElevenLabs about this. And so now hopefully this is very new. Literally the MCP update just dropped an hour ago. And so you can see we have a compose music feature here now. So what is exciting about ElevenLabs Music is that we've worked with the music industry and our partners to train the model only on licensed data. So we've, you know, acquired the data that we trained the model on, which also means that any music that is generated by the model can be used kind of commercially. And so this is quite exciting. So, okay, we got a 60-second upbeat song. Okay, let's play it, and fingers crossed. Okay, play audio.
Map the schedule down every line. Thor sync the slides, make the workflow shine. And the MCP's the backbone, Connect's in control. For ElevenLabs AI powering every role. Hands on deck, we build the dream. Digital teamwork, code on screen. From concept board to live stream glow. Tasting all magic, together we go.
All right. Yeah. So unfortunately, there's currently, I think, no tool to stop it, stop playing. So, but instead of listening kind of through that for a minute, but it gives you an idea that, you know, when we brought out kind of the ElevenLabs MCP server, so that's this one here, it's open source. You can try it out. You can put it into your Claude. So, you can also kind of generate speech with that. So actually what I think is the more exciting use case with Beeper, for example, is you could say, okay, generate kind of a podcast sort of summarizing all the, unread messages. And then basically on your way to work, you can just listen through that. And I think really the power now with MCP comes with, all these tools that we use in our daily lives, providing MCP servers. And now that means we can literally chain everything together and kind of build these applications that basically, access everything, no matter kind of what you're trying to achieve. And I think that is really kind of the exciting piece where we can get a user experience, where whatever we want to achieve, we just say it and it happens. So this is kind of the ElevenLabs MCP server and sort of the scenario where you can use that. Now, on the flip side, we've also built an MCP client. And this is specifically our conversational agents. Now, obviously, using kind of MCP servers within conversational agents is very, very powerful, because it means that your agent can, go out, it can access your beeper now, it can access all your messages, or it can, for example, access, your Supabase projects, which I've done here kind of in this scenario. So I've just kind of spun up an MCP proxy. So Supabase doesn't yet have kind of a hosted MCP server. So you basically spin up kind of a local MCP proxy. You can see that here. We can share the code as well. This is kind of shout out to Tambo, who kind of put that together as a demo, which is really cool. And then basically just using ngrok to sort of proxy that to ElevenLabs. So you can see here we have our Supabase MCP server, and we can see in this case now I've set no approval, so it can just kind of use all the tools. And so let's see kind of what that experience can sound like. And hopefully, let's see. Okay, we'll just need to use the right microphone. We have way too many microphones here.
Good afternoon, Thor. What's the plan for today?
Hey, Eleven, can you tell me what projects do I have in my Supabase account?
You have 8 Supabase projects. Talk to Santa Blob in EU West 1, Supabase User A Engineer Pack. In EU Central 1, Supabase V3 Speech. In US East 1, Supabase Chroma Pack. In US East 1, Supabase iCreator Pack. In US East 1, Supabase...
Okay, great. Yeah, that's I didn't want the region, but that's fantastic. Actually, can you tell me what database tables are on the ScribeBot project?
All right, for the ScribeBot project, you have one database table called transcription logs. It includes columns such as file type, duration, chat ID, message ID, username, transcript, language code, error ID, and creation timestamp.
Can you tell me the total number of transcriptions that were created, as well as the total sum of durations of all these transcriptions?
You've had 16,168 transcriptions created so far. Now let me just grab that total duration for you. And the total duration of all those transcriptions is 3,866,900.
What's that in hours?
That comes out to approximately 1,074.14 hours. That's a lot of listening.
Nice. Awesome. Thanks for that. That's all for today.
You're very welcome, Thor. I'm glad I could help. If you need anything else, just let me know. Have a great day.
So, okay, somehow I can't stop it listening. No, but this gives you an idea by, basically all these tools now being connected. And, this is kind of really what you would want it from Siri, right? Like when you say, hey, Siri, to actually get a useful response. And I think we're kind of now with MCP getting to that point where we can kind of connect all these systems together. And I think voice is a very compelling interface. for that, you know. So I'm excited to see more kind of voice, real-time voice interactions and agents, and yeah, very excited to see what, you know, everyone will glue together with all these upcoming MCP servers. So thanks so much for having me and listening. Appreciate it.
Amazing. This is the closest that I've ever seen technology come to Jarvis from Iron Man. You know, like the voice just makes it a different thing altogether. The experience is just so much more natural. Have a few questions from the chat, and then I have a few questions myself as well. So Kevin asks, can ElevenLabs Music API receive lyrics, or does it intake a prompt and compose the lyrics and the music itself?
Yeah, it can do both. So basically what you can do is you can put the lyrics into the prompt. So the API interface is literally just a text prompt that will generate a composition plan. And you can go, if you look at the API docs, you can go through that composition plan, and then you can modify the composition plan before you actually, you know, generate the music. So that is, you know, sort of a couple steps where you can sort of modify the output, but sort of the easiest way to get the lyrics into the music is by just putting it into the text prompt.
And then Masood asks, can it work on device or offline, or is this all API mediated at the moment?
No, for the time being, that is fully closed models that are only available on our own infrastructure. So these models are currently, yes, exclusively available through our platform.
That makes sense. This is also like very sophisticated infrastructure to set up and host yourself. So it won't, I don't think it's as easy as running it on your laptop just yet. And then I think Boris asks about content persistence and orchestration of multiple contexts. I'm guessing this is for the server side when like you're creating the music. And I actually had a question related to that as well, because I'm guessing the creation of music tasks can be quite long running. So how do you manage that overall? Like, what's the latency expected for the music generation? How does it orchestrate all that?
Yeah, I'm not entirely sure what the question is about. Not only music, any rack informed context. Also, maybe this is more about the conversational use case. Oh yeah, okay. So in kind of the use case of conversational agents. Yeah, so basically there is kind of a knowledge base component within this. So you can upload your knowledge base, or you can kind of connect it to server tools on your end if you kind of have your own rack systems. So basically our conversational AI infrastructure is kind of set up in a way where it is kind of the lowest latency possible in kind of streaming all these things together. However, you still have the flexibility to kind of inject your own tools and systems as you need it. So in the end, you know, if you kind of need persistence of the conversation history or something, you will need to inject kind of some tool that will store kind of the history and then retrieve it based on, say, the authenticated user. So you can have kind of a pre-conversation fetch where you inject basically certain information through kind of a webhook. So the agent would go off to your hook and like fetch the user information to initialize the conversation, and kind of that there are certain ways that you can ingest sort of the context and the history.
One of the cool things, Thor, that I noticed is you could probably hook up the ElevenLabs MCP server to the ElevenLabs MCP client, and you could converse with that MCP server to create songs. You know, like have that be in a tight loop, which you can just talk. It's your way to creating music, or really like utilizing the ElevenLabs API, which seems very cool.
Yeah. Cool. Any other questions?
I think there's one more from Masood about GDPR privacy regulations, and then we can move on to Batuhan after that.
Yeah, we have certain data residency. I think we just launched like India as well. Yeah, I think for GDPR and like SOC 2, HIPAA, kind of all that, best is you get in touch with the sales teams and they can let you know kind of what's possible there.
Awesome. Well, thank you so much, Thor. And also thanks for all the awesome questions so far. Keep that coming, and we'll make sure we answer them before the end of the session. And with that, Batuhan, please go ahead.
Perfect. So, hi everyone. Thanks again for having me. So this is Batuhan. I'm the head of product at Dria. And so at Dria, we are building a distributed inference runtime but on top of consumer grade hardware. So you can think it as like something like BitTorrent. It's a peer-to-peer network where everybody can contribute their compute. And instead of relying on data center GPUs, we are using that compute to run LLM inference. And on top of that inference, we are like shipping different products and services. So since Thor did the entire fun part, I picked two like boring topics for you. First, I will start with an autonomous prediction market fund powered by LLMs and like surrounded by MCPs. You can use it as an MCP server with cloud desktop application as well. And second, I'm going to introduce you something we are building again in Dria. It's an inference arena. So it's a benchmarking platform for like comparing different like inference benchmarks in terms of like different hardwares, different inference engines, or different large language models. Again, we also like turn that into an MCP server, so you can plug it into your agents as well. So let me start by sharing my screen. Right, I will do it again because. All right, you can see right now, right?
Yep, we see the
All
Excel.
right, perfect. Yeah, perfect. So this is a like very simple schema of the autonomous fund that is operating on top of the prediction market, which is Polymarket. Probably you know about the prediction markets, but these are financial markets that you can bet on the occurrence of real life events from like politics to like sports, etc. So they are a bit different than traditional financial markets. You don't need deep quant strategies to bet on prediction markets. So only thing that you need to do is to understand the current sentiment and the current status of real life events. You can just check the news and get an instinct, and relying on that, you can bet on the outcome of these real life events. By the way, this is not a financial advice. So that's why I decided to try this with LLMs, because like large language models are really good at digesting a lot of context compared to humans. So they can understand the current sentiment based on different like websites and resources, and then they can end up with making a decision about the occurrences of real life events. So there is a fund that is an autonomous fund that I have built with different tools and MCPs, and the fund entirely managing by an head of fund agent. So head of fund agent has access to different sub agents and different tools, starting with a market discovery agent. Sorry, this should be market research. I couldn't resist myself. So starting with the market discovery agent, it first fetches all the active markets from Polymarket API, and then tries to identify the markets with higher volume, sooner resolution date, or like proper probabilities about like higher earning potentials, and filters out them for the head of fund agent. After that point, the head of fund agent calls the market research agent, which like operates a lot of deep research call through the OpenAI API for every single market, like handed by the head of fund agent, and returns the reports for every single market out there. And after that point, the head of fund agent makes the financial decisions, fetches the portfolio, validates the trade options by reading the order book, like checking the current prices, etc., and then place the order to the Polymarket APIs, and finally sets an alarm for the like next market checking. So I've been running this entire setup in like 2 different models for the last 7 days. I will show you the results for first, and then we can jump into the cloud desktop use case. So at the left side, you're seeing the fund of GPT-5, and at the right side, we have the like Cloud Opus 4.1. I mean, both models, at the very beginning, both models didn't bet anything at all because I just gave them $150 and they didn't like the budget. So they were saying that, okay, I will wait until I get more funds, etc. But then I instructed them to motivate towards betting more, and they started betting. But if you check the like bet amounts and like probabilities, you can see that both of these models are very risk averse as they trained. So they are not like betting on lower probabilities or like higher opportunities in another way. But in the early results, we can see that GPT is kind of outperforming Cloud by losing less money. So we will try the same thing with the Cloud Desktop. So I turned every interaction between the poly market and the agents, like all these agent funds, into an MCP server so that you can like plug into Cloud Desktop and use for your own funds on poly market. So I started by asking my existing portfolio, and it seems like I'm losing a lot of money. I will try to reverse them with the help of Cloud. Let's ask for different markets. Are there any markets that we can bet and make profit? Fingers crossed. All right, so first it just asked for a few markets from the MCP, and there is like another like tool that it can leverage as well. So let me try that. Are there any markets for Bitcoin price? It can also search for some like certain topics, and if there are any markets, but apparently there isn't, it tries another call, and right now it finds some markets. So, all right, just give me a suggestion. Let's be direct to save some time. All right, let's pick this one. Sorry. Yes. First, it has to like check the current order book and the prices with the validate trade parameters tool. And then if they're validated, it is going to execute the trade. It simply like places an order on Polymarket. So this is my test portfolio. Let's see. And yes, here it is the order that is generated by the cloud itself. So as you can see, I only lose money. So this is not a financial advice. And the second thing that I want to show you is, so assuming that some of you are working with like some open source models, if you're hosting those models for yourself or even for individual users or like for enterprise use cases, then probably at some point you were looking for some kind of like performance benchmarks. And we noticed that there are no single platform that you can compare different performance metrics for different like inference engines or models. So we decided to build inference arena here at Dria, and let me show what it looks like. Here we go. So here you can like search for different models on different like hardware and like running by different inference engines. So what we simply do is we like provide you an apple-to-apple comparison for all these different combinations so that you can make better decisions while running these open source models with your own hardware or like renting some GPUs. And you can even like compare different like benchmarks in the same page. By the way, I'm using a VPN for Polymarket interactions. So that's why these APIs are not working pretty good. So let me try to compare two different setups. All right, let's try this one. You can compare different benchmarks in the same page, as I said, and there will be a lot of difference if you check for different inference engines or different kind of models. And you can like ask questions about like how to use those inference configurations, or they will be working well with your own use case. But we didn't want to limit this interactions with our own interface, because there are a lot of things to like explore with these numbers. And that's why we built an MCP server. So you can simply plug it into like Cloud or ChatGPT, but this time I would go with GPT just to be fair. So I asked GPT that I want to build a support agent for my platform to answer simple questions. And I expect 100 users per hour on it. What would be the monthly cost if I use GPT OSS 20B model? So it checked for some like results, and at the end, it kind of like estimated the entire cost for me, all the bandwidth, throughput, and latency that I'm going to receive from that specific configurations. And it can also like compare multiple benchmarks, because it can like ask for different benchmarks for different models or different configurations and compare them for you. So yeah, I think I'm done with the demos. So if you have any questions and if you have some time, I would love to answer them as well.
That's very cool, Batuhan. I think there's one question from Saidin about ability to switch to different models or engines based on a given task. So I think this is a model routing question. If that's like available out of the box, or if people have to configure that themselves.
I mean, if you want to compare different like models or different engines, you can right now you can just pick the ones that are already existing in the platform. But what we are working on right now is to like let you create on-demand like benchmarks for the selected engines, models, or like different kind of inference engines. And we are also working on adding like more hardware, especially focusing on individual use cases such as like Mac Minis, MacBooks, etc., instead of only NVIDIA GPUs.
That makes
yeah. So for getting contact, I saw that question. So you can like DM me on Twitter or LinkedIn if you prefer.
Someone asked about AI-driven high-frequency trading.
Yeah, I mean there are a couple of like projects that tries to do that, but I think if the market requires a lot of like financial analysis, then probably it would be better to use like traditional AI or machine learning systems instead of using large language models. But if it's a prediction market or something similar, that requires a lot of like context review and like trying to get insights from multiple sources, especially from textual sources, then large language models would be better off.
Makes sense. Also, any insights on how you built out that MCP server that you showed? Any learnings from that? Anything that worked, didn't work? Experiences from the tool selection?
Yeah, I mean, like I'm gonna be honest. Especially for the Polymarket fund, I built that like autonomous fund with OpenAI Agents SDK, and then like created a separate MCP server for all the tools for the Polymarket interactions. And then like 2 days ago, I just saw that you also have support for OpenAI Agents SDK. So probably I'm gonna turn that into like your version of with the MCP agent. And like in addition to those, both for the Polymarket fund and also the like inference arena agents that we have built in, we are going to turn them into MCP agents and expose them as an agent, so that you can like just use our own agent without like putting an effort to turn all those MCPs into agentic workflows.
Yeah. Wow. Thank you for setting up my my version, my part of the talk. That's exactly
No.
that actually.
I mean, MCPs are making like LLM's jobs easier to interact with external servers, but you are also making our jobs to like add MCPs to any pipeline with ease. So
with that, let me actually share my screen. Would love to maybe spend 10 minutes talking a little bit about that. And also, if there are more questions that folks have, please feel free to keep adding them. And I think Hani and folks can collect them. So actually, what I want to talk about is deep research as well, and the experience of building a deep research kind of architecture but built on MCP. And the key distinction there is traditional, like the first iteration of deep research workflows were all about web search. And so those agent architectures were really geared towards doing like web search really well. But one of the opportunities that we get now with MCP is we can actually model the same kinds of behaviors as tools. And those tools can do web search, but they can also perform actions. They can retrieve data from a database. They can write things. And so you can actually have a deep research style agent that is a lot richer in its functionality than the original version of like deep research that started out. And so actually, just as Batuhan was saying, a lot of the behaviors that we're starting to see in MCP servers are more and more agentic because these tools are starting to do more complex things. Thor showed a create music API, which does a lot of sophisticated things behind the scenes, and ElevenLabs has like all the infrastructure and stuff set up to make that possible. But like that's a complex workflow. It's not just querying something from a DB. And the initial iteration of a lot of MCP servers has been pretty much one-to-one to the REST API interfaces of those web services. But what we're seeing is a lot more tools are becoming agentic, where they do a couple of these complex things and then give a result back to the user. And the other thing you'll see is like a lot of the agentic behavior today happens on the client side, whether you're using Claude Code or Claude Desktop or ChatGPT. The client is the one that's deciding how to interact with these MCP servers and how to achieve the user's objective. But what if agents themselves are exposed as MCP servers? Then any MCP client could invoke, coordinate, and orchestrate those agents the same way that it does with any MCP server, like any existing MCP server. And what that really looks like is, you can have MCP clients like Claude and 11 and Cursor, et cetera, connected to standard MCP servers, but then they can also be connected to agents over the same protocol. And those agents in turn can be connected to other MCP servers all over the same communication protocol, which is MCP, which allows this very nice multi-agent orchestration happen all over the same tool-based like mechanism that MCP supports. The thing that enables is one, composability, because then you can do very complex things, kind of like the things that Batuhan you were showing, about trying to do 3 or 4 steps, but in one command. You can do that as an agent, and that agent can be a single workflow that gets kicked off. The second thing is those agents could be platform agnostic because you can build them once, but then you can use them in any MCP client. You could call them via voice, you could call them via text in Claude, you can, have them available in a line of business application. The agent functionality can be basically removed from the MCP client itself. And the last part, which is really important, is if these tools are long running and complex workflows, then you want that compute to happen externally from the client. The client may be running on your computer, it may be running locally, but the agent execution may happen remotely somewhere else on some dedicated infrastructure. And so it really creates that separation of concerns between the client and the agent. The other part of agents is they should be async workflows. So agents can be paused and resumed. They need to await for human feedback. Agents can fail and they need to be retried. They can also be triggered and scheduled like cron jobs. And so really agents are similar to async workflows where there can be long running tasks. They can pause, they can fail, they can retry. And so if you model that, then it's really like workflow orchestration that becomes. And that's really important for deep research and other kinds of long running workflows, because if things fail, you don't want things to just like have to be restarted from scratch. You want things to have a fault tolerance and durable execution kind of built into the architecture itself. The other thing we're seeing, kind of what I was mentioning earlier, is this agent architecture similar to like Claude Code and these more sophisticated agents that are modeled after deep research. And usually you see a lead planner agent, which is the orchestrator, that's the thing that's like connecting the main point of contact with a human that takes in a very arbitrary objective or task and tries to break it down into subtasks to accomplish the original objective. Then there are multiple sub-agents. So it's not just like a single LLM and you're stuffing everything into the prompt context window of a single LLM session. You're really breaking down tasks and assigning them to different sub-agents. And you might even be creating these agents dynamically on the fly. The other important part is they all have MCP access. Like that's the way that we're seeing connections to tools and services now is all standardized over MCP. And then as agents become MCP servers, you can actually connect to other agents over MCP as well. And lastly, they're durable. These are like long-running async workflows. You may kick off like a music generation job, and maybe it's like for a whole movie soundtrack or something, and that may take a really long time to finish. And so those are like async workflows that get triggered, and then you can check the status of them asynchronously. You can have human in the loop that gives feedback, and like you can basically model it as a workflow or orchestration problem. So a couple of concrete recommendations based on that, which I'll show in a demo as well. First is all you need really to connect LLMs to tools and services and data is MCP. And so that's really the way to model any tool call, any external interaction that an LLM needs to have with the world around it. The second thing is we, at least with mcp-agent, have discovered that modeling agents as workflows that are hosted on things like temporal, like a proper workflow orchestration engine, is really important for fault tolerance and durable execution. So I would highly recommend using a proper execution orchestration backend for agent workflows. And then starting pretty simple is really important. A lot of the best performing agents actually have very simple architectures. We're going to publish a blog post soon on like kind of our learnings of building deep research agents with MCP. There were some really interesting kind of obvious insights that were not intuitive to us. So we'll share that probably in the next week or so. And then none of these agents are like fully autonomous. In almost all of these cases, as you saw in all the demos as well, you need a human in the loop to be able to guide the agent to do the right thing. And finally, related to that is actually setting up evals for MCP servers. That's going to be really important going forward as these servers become more and more complex. And the next session that we're going to do, the next webinar, is going to be all about some of those learnings as well. So actually, let me talk about the finance agent. And this is a pretty classical kind of deep research architecture, similar to Batuhan, the thing you had shown as well, in terms of just doing financial analysis. And again, this is not financial advice, but you're able to like do deep research for stocks and things. And so let me just show you what that looks like. So here we're gonna do this analysis for the meta stock. I have this recorded in a demo because, as you can imagine, deep research does take quite a while to execute. And so we kick this off, and really the goal that we set, the objective we set, was to do deep research on the meta stock financials and compare it across a bunch of different quarters. And so here the agent kicks off its run. This is all CLI, so there's a like client-based interaction model for this agent. And you can kind of see, for folks who've used Claude Code or other kinds of deep research agents, a very familiar kind of architecture. The first thing you'll see is a set of to-do tasks on how the agent, the lead orchestration agent, has broken down the task into a series of sub-steps, which it's each gonna organize and execute in parallel or in sequence. It's like has a kind of like an orchestration view of the plan. And as it executes, you can actually set budget as well. So you can say, I want to use a maximum of 100,000 tokens for this workflow. I want like it to run for a maximum of 10 minutes, and I want it to cost a maximum of $1. And if any of those things is like exceeds that limit, then it will immediately finish this workflow and publish whatever like findings it's found so far. Then on the top right, you'll see memory. This is basically this idea that as the agent is going about exploring, it's generating knowledge, it's gathering information, and so it's going to start storing those artifacts so that those can be referenced by later steps of the workflow to produce a very well thought out, well researched kind of report. And I'll show you in a bit that like none of this is actually anything different from an MCP-based agent. The way that it's collecting, getting the current stock price or gathering financial ratios, or eventually it's going to write all of this to an Excel sheet. It's all done with MCP tools. And so this will take a while to run. It's like you can see which steps it's executing, what it's completed. There are some things that are pending. If things fail, they will retry from that point in time. It won't like restart the whole workflow. And all of these things are pretty important. And remember, the original objective is conduct comprehensive financial research on meta platforms. And so that's like a fairly open-ended task that it's very intelligently trying to break down into specific things. And so you can kind of see it running, and after a while, this will finish, and you can actually see that how many tokens it used. It used 63,000 tokens in total. It costs 6 cents, and it took 5 minutes to run. So all of those are like below the budget that we had set it. If it had exceeded any of those, it would have immediately triggered and like a report generation. And then you can also see the knowledge that it's extracted as part of this. And then it generates a cohesive report in an Excel sheet. So what it generated was actually something like this, and I'll just zoom in a little bit. And it generates it across a few columns. So it creates one across like, it generates things around revenue, breaks down revenue across different sections of the company, across 2022, 2023, 24. And so you can kind of see a very nice, clean way of visualizing this information, similar to how I would imagine like a financial analyst would kind of analyze this kind of information. And the way we built this, this is all open source. It's in the mcp-agent repo. Is this like, this is going to be open source, the example application as well in the next week or so. But really, there's a deep orchestrator, and you set the configuration. You define which MCP servers you give it access to. And the MCP servers are just defined in this config YAML as this, basically there's a fetch server for connecting to the internet, fetching data, URLs, etc. File system to write things to disk, and then the Excel MCP server for actually like writing an Excel file. And that's all you really need to configure the deep orchestrator. You can give it a bit like specific agents that you've configured yourself, or you just give it the servers and it will get the original objective and it will go figure out how to accomplish this. And so here's like the prompt, which really matters, being very precise about the prompt. And then you give it a budget of how much like, tokens or cost or the time that you want to allocate this workflow. And then all you do is just like run this orchestrator and it kind of produces what I just showed you. And the way the deep orchestrator is architected is actually like fairly simple, where a user objective comes in, we generate a plan, and the plan is basically a set of to-do tasks. So there's a queue of tasks that it's managing. It starts executing those tasks immediately. It starts extracting knowledge from those. It makes the MCP tool calls. It checks if the objective has been accomplished. And if not, it continues to execute the tasks, or it triggers a replan where it says, based on like what I've accomplished so far, what are the next set of steps that I need to take in order to continue towards the objective. And it basically runs all of this in a loop until this policy engine is satisfied that we've accomplished the objective. And then you synthesize the results and return that final response back to the user. And all of this is basically like abstractions that we've created on top of MCP. There's no knowledge here of like how you call a tool to fetch like data from the internet versus calling a DB like Thor showed Supabase integration. All of that is done over MCP, which makes this super powerful because now for the first time, you can actually like just by virtue of connecting to different MCP servers, have an agent that does deep research over any kind of like database or tool that's accessible over MCP. And then really the part that we built that took a little bit of iteration and setup was all this architecture for how to build a deep research agent properly. And we took learnings from Anthropic's deep research agent. Gina AI had some learnings as well, and a few others that we'll share in the blog post. But the key learnings were you kind of separate out the task queue from the agent's prompt. You also separate out the working memory. So you basically give the agent like a scratch pad where it gathers artifacts and things it's learned. And then you kind of like plan out give the agent the ability to plan out a series of steps instead of just one next step to try to figure out like what to do next. And we found that like if you ask the agent to think for like the next 5 steps, it does a lot better than if you just ask it to think about the immediate next step it needs to do, which is pretty counterintuitive to us. And then you have like things where you can make it more efficient, like a cache for agents and the budget tracking and all that. But really the fundamental piece of it is very simple. It's really running this a plan in a loop until the objective is accomplished, and letting the MCP be the way that the agent connects to all of these pieces around it. And so I think we can share the link for this in the GitHub afterwards as well, but would love feedback on trying this out. So far, we've tried this on read-only tasks, but one of the next things that we're pretty excited about is trying to look at like, how do you perform actions that are more complex and sophisticated, like write operations maybe on your database using the same kind of architecture. And then the last thing I wanted to talk about was just problems that are yet to be solved in the space, both as food for thought and also as topics that we'll probably cover in the coming sessions. So the first thing is long-running tools are kind of not really well modeled in MCP right now. Like, what if a tool takes hours to run? Like maybe it's a video generation task or a really large song generation task. So that's like an ongoing problem that there are folks in the community that are trying to think about and solve. Agent authentication and authorization, especially for these places that have sensitive information, is really critical. And who should the identity of the agent be? Should it be like should it assume the identity of the person who invoked the agent? Should it have its own service user identity? There are all these like kind of questions that need to be resolved. Agents that like learn from their experience, so self-improving agents, almost like RL for agents, is another really interesting thing that people are starting to look at. And then really like the hard thing right now is figuring out how to give the right context to agents at the right time and have them do the right thing. And that involves context management and tool management. We've heard about like some MCP servers that have 10,000 plus tools now. And so how do you like, manage that? And you can't give the LLM access to all those tools all at the same time. And so that gets very tricky very quickly. And finally, how do you like give feedback as a human to these agentic workflows, especially when they're long running operations? So that's some of the stuff that like we're thinking about and a whole bunch of people in the community are thinking about. I'll pause there and I'd love to take a few questions as well. But most importantly, I just wanted to thank everybody who tuned in to join us on this inaugural session. And also a huge thank you to Thor and to Batuhan for joining as well. This was like super fun, as well as I could have hoped, to be honest.
Likewise. Thanks for setting this up, guys.
Amazing. Cool. I think maybe we can do the questions. We're already like running pretty out of time. So maybe we'll respond to some of the questions when we upload this to social media later this week. But yeah, thank you everybody for tuning in and hope you all have a great rest of your day. All right. Bye everybody.
Take care.